Okay, let's read this next part. It says, now use the definition of derivative to find the derivative of the following functions. See if you can notice a pattern. So we're going to go ahead and do it for the derivative of 0, x, x squared, x cubed. Then we're going to guess what it is for x to the 10th, and then we're going to see if we can find it in general. But it does want us to use that definition of derivative, and because it says definition of derivative, that means I need to bust out my limits, okay? So I'm going to do this over to the side here. You might need a separate piece of paper to do this, but let's see if we can do this. Let's look at the first one we're going to do is f of x equals 0. We're going to do the limit is h for every single one of these. We're going to be using the definition of derivative, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's the definition of a derivative. We're going to be using that for every single one of these. So to find the derivative of f of x equals 0, f prime of x would be equal to the limit as h approaches 0 of f of x plus h. So look at the function. Anywhere you see an x, plug in x plus h, well, that's simply just 0, or function 0, minus the original function, which is 0, all over h. Well, 0 minus 0 is 0. So this is the limit as h approaches 0 of 0 over h, but 0 over h is just 0. So this is the limit as h approaches 0 of 0, and that's a constant, right? And the limit of a constant is that constant, so we get an answer of 0. Let's move on to the next one. I'll do it in a different color. How about f of x equals x is the next one they wanted to do. So if we did f prime of x here, we would be finding the limit as h approaches 0 of f of x plus h. So in that case, look at your original function. Where there's an x, you'd plug in x plus h, right? So this would be x plus h minus the original function, which is just x, all over h. Well, notice what happens. Our x's cancel here. So I'm left with the limit as, this should be an h approaches 0. Limit as h approaches 0 of, well, we just have h over h, but those simplify into a 1. So this is the limit as h approaches 0 of 1. The limit of a constant is the constant, so the answer is just 1. So we come up here, and the answer for the derivative of x is just 1. For the previous one, it was 0. Let's go ahead and try it for x squared now. Use a different color for you. How about f of x equals x squared? So if we want to find f prime of x, it's going to be the limit as h approaches 0 of f of x plus h. So wherever we see an x, we plug in x plus h in parentheses. So that'd be x plus h quantity squared minus f of x, the original function, which is x squared, all over h. Okay, well, we got to do some foiling out here. If you watched the previous section, you saw that. X plus h quantity squared would be x squared plus 2xh plus h squared. I get that from foiling x plus h quantity squared. Then we still have that minus x squared. This is all over h. Notice our x squareds here cancel. So I'm left with the limit as h approaches 0 of 2xh plus h squared all over h. Well, this was where we tried to factor out an h on the top, which we're able to do. So that would be the limit as h approaches 0 of h times 2xh divided by h is 2x. H squared divided by h is just h. So the factored version of the numerator is h times 2x plus h. It's all over h. Now my h's simplify, and only now because it's factored, right? So this is the limit as h approaches 0 of 2x plus h. When we do that, this should be the limit as h approaches 0. The h would go to a 0, so this would be 2x plus 0, which is simply 2x. So what's the derivative of x squared? The derivative of x squared is 2x. Okay, let's continue on. I'm going to do this one right below it. I need to do x cubed now using the definition of derivative. So our function, I'll use green here, is f of x equals x cubed. So f prime of x equals the limit as h approaches 0 of f of x plus h. So wherever I see an x, I need to plug in x plus h. So this would be x plus h quantity cubed minus the original function, which is x cubed, all over h. Okay, this is where I'm going to ask you to go to the previous section, because we already did the math for this. We already did x plus h quantity cubed. So what I want you to do is reference the previous section, 3.1, and look out, or you could just do it again. The limit as h approaches 0. Do x plus h times x plus h times x plus h. And let's see what you get. So what we got when we FOILed that out before was x cubed plus 3x squared h plus x h squared plus h cubed. So that's what that ended foiling out to be when you multiplied out x plus h times x plus h times x plus h and combined like terms. We need to subtract off the original function, which was x cubed, and that's all over h. Okay, so what happens? Well, we notice that the x cubes cancel. I'm going to do 2 steps in one to save some room here because I'm almost out of room. What I'm going to do is I'm going to look at all the remaining terms, and I'm going to realize there's an h in common in each one of those terms. So when I factor out that h, it would be h times, well, the first term would be 3x squared h divided by h is 3x squared. 3xh squared divided by h is 3xh, and h cubed divided by h is h squared. All of this is over h. Our h is simplified. That left us with the limit as h approaches 0 of 3x squared plus 3xh plus h squared. And so the idea is anywhere we see an h, we're going to plug in a 0. Anywhere we see an h, we plug in a 0. So I'm getting now we've evaluated the limit, so I don't need to write the limit anymore. I'm getting 3x squared plus 3x times 0, which is just 0, plus 0 squared, which is also just 0. So that goes to a 0, that goes to a 0, so I'm getting 3x squared. So what's the derivative of x cubed? The answer is 3x squared. Okay. So now the idea is, could you figure out the derivative of x to the 10th? So if you think about that, think about the limit process. You would need to do x plus h quantity to the 10th, which means you would have to do x plus h times x plus h times x plus h times x 10 times. It would be miserable. It would take forever. So what I really wanted to do is I wanted you to look at this. The derivative of 0 is the same thing as the derivative with respect to x of x. That's not true. Not of x to the 0. That one's perfectly fine. Really should be a 1, but that's okay. How about the derivative with respect to x is the derivative of x to the 1. And when we got our answer, I want you to look at this as 1x to the 0. Okay? And the derivative with respect to x of x squared was 2x, but what I want you to look at that as is 2x to the first power. And the derivative of x cubed was 3x squared. So I'm asking you, do you notice a pattern? Does it seem like you can see what's happening? Well, it seems to me when I take the derivative of x to the power, I drop that power down in front. So here's x cubed, right? Drop that power down in front and then subtract 1 from the power. So what should it be if we want to find the derivative with respect to x of x to the 10th? We should drop that power down in front, keep the x to the power minus 1. And that's exactly what it would be. The derivative of x to the 10th is 10x to the 9th. In general, what it is, the derivative of x to any power, drop that power, x to the n minus 1. That right there is just an observation that we notice from doing the limit process for several different x's to certain different powers. And that's what's called the power rule. So the power rule says exactly what we just figured out. The derivative with respect to x of x to the n is nx to the n minus 1. That is one of the most powerful rules, one of the rules that we're going to use absolutely the most this semester. So please make sure you know that. Drop the power and then subtract 1 from the power. I do want you to notice that x has to be in the numerator. You're going to see many varieties of this, including on this page and in this packet, but throughout the semester. It says, note, the power rule only works when you have x raised to the power. It is key that x is not in the denominator or underneath a radical. So let's say that again. This is really important for us to understand. The power rule only works when you have x raised to a power. It is key that x is not in the denominator or underneath a radical. So I'm going to show you how to deal with that in just a moment. And then it also says, note that the derivative with respect to x of x is just 1, because it would be x to the 1. So you drop it, it would be 1x to the 0, which is really 1 times 1, which is just 1. So the derivative of x is just 1. So let's see some examples of this. What then would be the derivative of x cubed is? X cubed, again, we do not have to use the definition of derivative. So when we do this, we would say f prime of x. We do need to write it as the derivative would be 3x to the 3 minus 1. Drop the power and then do the power minus 1, which is 3x squared. Because that's the only part of that problem, yes, I do want to see you doing the power minus 1. But that's not going to be necessary later in the semester when this is just part of a bigger problem, right? It's the only part of the problem. All right, so let's look at B. This one's really good for us to look at. It says g of x equals the cube root of x. Well, if you read just above, it said it's really important that x is not underneath a radical. Well, as part of that algebra review and the lines and functions review, what I reminded you is you're going to have to go from radical to exponential form and back numerous times. So the cube root of x, you should be comfortable with saying this is the same thing as x to the 1/3 power. So that means when I want to find the derivative using the power rule, not the limit process, I'm using the power rule now. What I'm going to do is I'm going to drop that power, which would be 1/3. I do x, and then I do that power minus 1. So this would be 1/3 x to the, well, 1/3 minus 1. Please, 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 with fractions, use your calculator. That is negative 2/3. Okay, a couple of things we have to remember here. We cannot ever put a final answer with negative exponents. In fact, no negative exponents is what I'm going to write down here, okay? So this is the same thing as, and if you remember dealing with negative exponents in the review chapters, or in the review sections, all you have to do is throw it into the denominator and make the power positives. So this would be 1/3x to the 2/3. And then I'm going to write a second note. My second note is going to be, if it starts as a radical, it ends as a radical. It should end as a radical. So to find the derivative, we changed it into exponential form. And when you look at it right now, it is in exponential form. But because it started as a radical, we need it to end as a radical. So in other words, convert this exponential form back to radical form. So this would be 1/3 and then x to the 2/3. The denominator tells you the root, so that's the cube root of, and then the power stays the power. The numerator stays the power. So the derivative of x to the 1/3 is 1/3 times the cube root of x squared. That would be the derivative of x to the 1/3 right there. Notice this was significantly easier using the power rule than it is the definition of a derivative. No limit process anymore. Let's go ahead and look at C. C is y equals 1/x squared. Again, x cannot be under the radical and x cannot be in the denominator. So what do we do in a case like this when x is in the denominator? Well, we do what we just saw in the previous problem, which is we can move x into the numerator as long as we make the power negative. So 1/x squared is the exact same thing as x to the -2. Okay, so now if I want to find my derivative, I'll call it y prime here. I'm going to drop that power, -2, x to the -2 minus 1, the power minus 1. So this would be -2x to the -3. But then remember, we cannot have negative exponents in our final answer. It's not an option. So what do we move to the denominator? Remember, we cannot move the -2 to the denominator unless it's in parentheses. That -2 is not in parentheses, so the -2 has to stay up. Only the x is coming down to the denominator. So the final answer to the problem would be -2/x cubed. Okay.